Now, an asteroid that was spotted late last year by space scientists is being carefully tracked. And speaking of which, scientists are once again sounding the alarm about a particular space rock with a slightly dramatic personality. Asteroid 2024 YR4. This isn't your average asteroid. It's got an unpredictable orbit which has kept astronomers on their toes since the moment it was discovered late in 2024. At first, when it showed up on our radar, there was a small but noticeable chance it might slam into Earth. That might sound low, but when it comes to space, even a 1% risk is enough to get everyone's attention. Headlines flew across the internet claiming the James Webb Space Telescope had confirmed one of our oldest fears. A city-killer asteroid was on a direct collision course. But here's the twist. The story of what the world's most powerful telescopes actually discovered is far more interesting and ultimately more reassuring. We're here to separate the panic from the planetary science. To do that, we need to go back to the very beginning to uncover the truth behind this asteroid's very close encounter with Earth. Our story kicks off not with Webb, but on Christmas Day 2024 at an observatory in Chile. Here, a tireless network of telescopes called the Asteroid Terrestrial Impact Last Alert System, or ATLAS, was doing what it does every night, scanning the sky for anything that moves. Just 2 days after making a close flyby of Earth, the system flagged a new object on December 27th. It was faint, fast, and its trajectory was immediately concerning. They named it 2024 YR4. Within days, the Minor Planet Center had enough data to calculate a preliminary orbit, and that's when the first real wave of concern began. The initial path showed 2024 YR4 wasn't just another rock passing by. Its orbit was predicted to intersect with Earth's on a very specific date, December 22, 2032. Now, the problem with a new discovery is that the first few observations are like seeing a speeding car for just a split second. You have a general idea of its direction, but tiny uncertainties can lead to wildly different outcomes down the road. For 2024 YR4, that cone of uncertainty was uncomfortably wide, and somewhere inside it was a direct impact with our planet. The initial calculations suggested a small but non-zero chance of collision, and as more data trickled in, the probability didn't disappear. In fact, for a little while, it started to climb, making things a little more tense. To understand just how serious this was, we need to talk about the Torino scale. It's a 0 to 10 color-coded system for communicating asteroid threats. 0 is white, meaning no hazard. 1 is green for a routine discovery. By late January 2025, 2024 YR4 was elevated to a Torino scale rating of 3. This is the yellow zone. A level 3 means a close encounter, meriting attention by astronomers with a 1% or greater chance of a collision capable of localized destruction. For perspective, this is incredibly rare. 2024 YR4 became only the second asteroid in history, after the infamous Apophis, to reach a rating this high. The International Asteroid Warning Network, or IWAN, issued an official notification triggering a global, coordinated campaign. This wasn't panic, it was procedure. Telescopes around the world were tasked with one simple goal: shrink that cone of uncertainty. As February 2025 progressed, the impact probability, which had started around 1%, peaked at a startling 3.1%, a 1 in 32 chance of impact. Not exactly comforting. This made it the most significant impact risk tracked in over 2 decades. To put that in perspective, NASA believes this asteroid is around 60 meters across. That's eerily similar to the size of the object that caused the infamous Tunguska explosion in 1908. Remember that? A mysterious blast over Siberia that flattened over 2,000 square kilometers of forest without even touching the ground. Devastating, right? This is where the viral headlines found their fuel. And it's also where the James Webb Space Telescope enters the story, but not as a harbinger of doom. It was the key to our salvation from uncertainty.
The global observation campaign was working. With each passing day in late February 2025, new data was fed into the computers at NASA and the European Space Agency. The impact probability began to fall, just as scientists hoped. It dropped from its 3.1% peak all the way down until the Torino scale rating was lowered from 3 to 1 and then finally to 0. The danger was receding, but there was still a statistical ghost in the machine that had to be extinguished. This is where Webb played its decisive role. In March 2025, the Space Telescope turned its golden eye towards the asteroid. Unlike ground-based telescopes that see reflected light, Webb can detect thermal emissions, the heat radiated by the asteroid itself. This is crucial. Why? Simple physics. A small, shiny asteroid can look just as bright as a large, dark one, but its heat signature is a direct indicator of its true size. Webb's observations were revolutionary. The data allowed scientists to nail down the asteroid's size to roughly 60 meters in diameter, about the size of a 15-story building. But more importantly, Webb's incredibly precise tracking provided the final data points needed to refine its orbit with pinpoint accuracy. By early March 2025, the news was confirmed. NASA, the ESA, and other agencies all concluded the chance of an Earth impact in 2032 was zero. The threat was gone. The system worked exactly as it was designed to. So the very instrument that viral headlines claimed had confirmed a threat was in reality the one that provided the conclusive evidence of our safety. But hold on, don't get too comfortable, because while Earth might be safe, the Moon could be in trouble. The very same calculations that cleared Earth's path placed our closest neighbor directly in the line of sight. Thanks to the sharper eyes of the Webb telescope, scientists have updated the risk. As of the latest analysis, there is now a 4.3% chance, about 1 in 23, that asteroid 2024 YR4 will collide with the Moon on or around December 22, 2032. So, what would happen? First, it poses absolutely no danger to us here on Earth. The impact would not alter the Moon's orbit in any meaningful way. What it would do, however, is create a spectacular event. According to Paul Wiegert, a physicist from the University of Western Ontario and lead author of a recent study, the impact would release energy equal to millions of tons of TNT, carving out a new crater about 1 kilometer wide. This would be the largest lunar impact in thousands of years. If the impact occurs on the near side of the Moon, the initial flash might be visible from Earth with binoculars or a small telescope. But here's where it gets even more concerning. The blast could launch around 100 million tons of lunar rock and dust into space. A significant chunk of that debris could be thrown on a path toward Earth. This debris isn't just space dust. It's high-speed ejecta. It could pose a real hazard for the thousands of satellites in low Earth orbit we depend on for GPS, communication, and weather forecasting. And here's where things get dramatic. If even a small amount of that debris enters Earth's atmosphere, we could witness one of the most dazzling meteor showers in human history. Not a fiery harbinger of destruction, but a beautiful, harmless shower of genuine moon rocks lighting up the sky. This, then, is the real story behind our title. The story of 2024 YR4 is a powerful reminder that we live in a dynamic cosmic neighborhood. But it's also a story of incredible ingenuity. What do you think is the most important lesson from this close call? Drop your thoughts in the comments. We'd love to hear your take. In the end, the saga of 2024 YR4 transformed from a potential disaster into a triumph of planetary defense. A threat emerged from the darkness and was met by a coordinated global response. The Atlas survey gave us the early warning. A network of telescopes refined the orbit, and the James Webb Space Telescope delivered the final, conclusive data. This entire event proves the critical importance of programs like NASA's DART mission and the upcoming NEO Surveyor telescope. We can't stop asteroids from coming near Earth, but we are getting better and better at seeing them long before they pose a genuine threat. The sky is not falling. In fact, thanks to the tireless work of scientists, it's safer than ever. And as we look toward 2032, we do so not with fear, but with scientific curiosity. We may be lucky enough to witness a new crater being born on our moon and see a gentle shower of its dust in our skies, a safe and spectacular reminder of the power of the cosmos. If you enjoyed this deep dive into cosmic threats and planetary defense, be sure to subscribe and turn on notifications. Until next time, keep looking up, because space isn't just fascinating, it might be our next big challenge.